So aim of this experiment is to plot the speed torque characteristics of an AC servo motor. So the apparatus required for this experiment are, we need a servo motor, we need experimental setup for the servo motor, we need an MC type voltmeter, we need MI type voltmeter of 0 to 150 volts and MC type voltmeter of 0 to 5 volts, and we need some patch cords or some connecting wires. Okay, so this is the AC servo motor. So we know in the AC servo motor there will be two windings. One is the reference winding and the control winding, and these two windings will have a phase displacement of 90 degree. Okay, so this is the AC servo motor kit. So you can see two digital displays here. This one is to this digital display gives us the current, and this display gives us the speed. Okay, and so you can, this is the front panel of this kit, and you can see this is a servo motor which is consisting of this control winding and reference winding. This is the rotor of the servo motor. The rotor of the servo motor is coupled to the armature of the DC motor. Okay, so initially, since the rotor of this servo motor is coupled to the armature of the DC motor, if you carefully see this image, I don't know whether you are able to read. This is DC motor. Okay, this is the armature of the DC motor. This is the rotor of the servo motor. Both are mechanically coupled. So initially, supply is given to the DC motor. Okay, and speed of the servo motor is monitored. Okay, with the variation in the supply volt. Okay, so this is the front panel, clear image. So in this front panel of this AC servo motor kit, you can see a load switch. Okay, this is the load switch. This is AC servo motor switch. This is power supply switch, main supply. Okay, so this is a load control knob, and this is speed control knob. Okay, so this is the display, digital display, okay, which gives the load current, and this is the speed display. Okay, digital, these two are the digital displays. Okay, so let us see the procedure how to do the experiment. Okay, so initially in this experiment, the load switch is kept in off position. This is the load switch which is kept in off position. This indicates that load is off, means that armature circuit of this DC machine is not connected to the auxiliary power supply. That's all, isn't it? So you can see here in this image, this is the load switch. This is kept open. When it is open, that means that armature is not connected to the supply. Okay. So AC servo motor switch is also in off position. Okay, and we must before starting the experiment, of course power supply is also in off position, and before starting the experiment we must make sure that this load controls knob and speed control knobs are completely rotated in anti-clockwise direction, means they are in initial position. So P1 and P2 knobs, okay, they must be in anti-clockwise, they must be rotated in anti-clockwise direction to make sure that they are in the initial position. Okay, so P1, P2 should be in initial position. Now we must connect an MC type MC type voltmeter of range 0 to 5 volts across this DC TP1. Okay, so of course in this panel you can see three connections are shown here, but in our laboratory these many connections will not be there. Okay, so I will show you the kit. You have to connect this MC type voltmeter here. Okay, see here. So to measure the induced back EMF in the armature of your motor, DC motor. Okay, now after connecting a DC type voltmeter here, okay, no other connection is required. Okay, simply you connect a DC voltmeter across these two knobs. Okay, now switch on the main power supply. This is the main power supply. Now switch on the main power supply and AC servo motor switch. Okay, so according to this, this is our AC servo motor switch. You have to switch it on. Okay, now as soon as you switch on the supply, we can observe that AC servo motor starts to rotate. Okay, and you can note down the speed from this front panel digital display. Okay, so the here load switch is still in off position. Okay, so okay, from this panel level, this load switch is still in off position. You have turned on the main power supply and you have turned on the AC servo motor. Okay, now what you have to do is you must vary P1 gradually in clockwise direction. As you vary P1 in clockwise direction, the speed that is displayed on this digital display will vary, as well as the back EMF that is induced in the DC motor will be displayed. You can monitor it or you can observe it in the voltmeter. Okay, so as the speed control knob is varied, okay, P1 is varied, it is rotated in a clockwise direction, the induced back EMF in the motor will vary. As the induced back EMF in the motor, DC motor is varying, the speed of the servo motor will also vary. So you can note down the back EMF induced in the DC motor and the speed of the servo motor in this tabular form. Simply what you have to do is, you have to vary P1. Okay, as P1 is varied, gradually the induced back EMF in the DC motor and the speed of the servo motor will vary. Note down the values in the table. Okay, so after noting down the values in this table, you have to plot the graph. Okay, so the graph that you are going to get, back EMF versus speed, this will be the characteristics for back EMF versus speed. Okay, so you will get, if this is the expected graph. Okay, now bring back this knob to initial position and turn off this AC servo motor switch and the power supply switch. Okay, now connect an AC voltmeter, that is MI type voltmeter of 0 to 150 volts across AC TPS. Okay, means across these two terminals, across the control winding of your AC servo motor. Okay, so already there is a DC means MC type voltmeter across this DC motor armature, and now you are connecting an MI type voltmeter across the control winding of your servo motor. Now we have two voltmeters connected in this circuit. Now turn on the supply. Okay, turn on the AC servo motor and also turn on the load switch. Okay, so you have to turn on the load switch also. You have to turn on all the switches. Okay, power supply, AC servo motor switch as well as load switch. Okay, after that, using this control, you can see here control voltage. Okay, so using this control voltage knob, okay, you just set some voltage in the MI type voltmeter. Okay, you set some voltage in the MI type voltmeter. As you vary this knob, okay, as you vary this control voltage knob, the voltage in the AC, that is MI type voltmeter, will vary. You set some voltage of 40 volts. Okay, by varying this control voltage, set some voltage of 40 volts in the AC voltmeter, that is MI type voltmeter. After setting a voltage of 40 volts by varying this, okay, now stop varying this knob. Now vary the load knob here. Okay, so as you vary the load knob, okay, the current in the AC servo motor as well as the speed, how the speed of the AC servo motor is varying, you can monitor, as well as the back EMF in the DC motor can also be noted. Okay, so what you have to do is, second experiment in this is, simply you have to connect an MI type voltmeter of 0 to 150 volts and you have to vary this control voltage knob. As you vary this control voltage knob, the voltage reading in the MI type voltmeter will vary. You have to set the voltage, you have to vary this knob in clockwise direction till this voltmeter reads 40 volts. Okay, you can take 40, 50, 60, whatever you want. I am telling some value. Okay, you just stop varying this. Now vary this load knob. As you vary this load knob in clockwise, you can see the since all the switches are on, load switch, servo motor switch, and power supply switch, all the switches are on. You can see the current in this servo motor and the speed of the servo motor, and you can even note down the back EMF induced in the DC motor. Okay, so you can consider any term as reference. I have considered current in the display. Okay, digital display as the reference. Initially from 0 I have started. Okay, so as I vary the load knob, okay, so the current in this digital display will vary. Okay, speed will vary and back EMF will vary. Okay, so I have taken some readings. Okay, for 50-50 difference. Okay, so with 50 milliamperes difference, I have taken the readings. Okay, and you can note down the speed as well as back EMF. Okay, speed from the digital display. Of course, this IA will also, you can note down this IA from the digital display only. Back EMF you can note down from the voltmeter. And control voltage is what? 40 volts. It is fixed. Okay, and just calculate power P equal to EB into IA. Okay, which are available in the tabular form. After that, you can determine the torque. Torque is given by P into 1.019 into 10 power 4. Okay, 10 power 4 into 60 by 2 pi n Newton meter. This is the formula to determine the torque of the servo motor. Okay, you will get some torque values, power values, back EMF and speed in this tabular form. Again, repeat the procedure. Okay, now vary the control voltage. Okay, so bring back this load switch, load knob to initial position in the anti-clockwise direction. You rotate it in anti-clockwise direction, bring it back to the initial position. Now vary this control voltage till this MI type voltmeter shows 50 volts. Okay, earlier you have varied this control voltage knob till the MI type voltmeter reads 40 volts. Now increase that control voltage value to 50 volts. Okay, and leave this knob. Now vary this load knob. Okay, in clockwise direction, and note down the IA value, N value and EB value in the next tabular form. Okay, in this tabular form, and same, you can take same readings. Okay, so in for this case, you may not get initially, current may not be 0. Okay, current may not be 0. For the first case, you may get 0, you may not get 0. Okay, I have, for reference, I have given these values. Initially, you may get some current around 30 amperes, milliamperes. Okay, so it may not be 0. I have written, just for example, I have written here, it may be around 30 milliamperes or 20 milliamperes. Okay, and your wish, with some proper scaling, you just as you vary the load knob, IA will be varying. Okay, and you note down the speed and back EMF. Okay, so it need initial value IA, it need not be 0. Okay, it may be 0. We can't say. While doing the experiment, you will be knowing whether you will get the 0 value or not. If you get the 0, you just note it down. That's all. Okay, so for different values of IA, note down the speed. For I'm talking about this 50 volts. Okay, control voltage is 50 volts. Note down the speed, back EMF, calculate P equal to EB into IA, and determine the torque by this formula. P into 1.019 into 10 power 4 into 60 by 2 pi n. Torque equation you people already know because you had this subject in your control systems. Okay, so now after taking few readings around 5 to 6 readings, okay, what you do is you again bring back this load knob to its initial position, rotating it in the anti-clockwise direction. Okay, now vary this control voltage to 60 volts. Okay, You can see those 60 volts in the MI type voltmeter. Now vary this load knob gradually, okay, so in clockwise direction, and note down IA, N, and EB, okay, okay, and the current may not be 0, okay, okay, some value you will get, and taking current as reference, note down the speed, EB, calculate the power and torque by using these formulas, okay, and you have for 3 different control voltages, you have note down this current in milliampere, speed in revolutions per minute, back EMF, power and torque. Now you can plot the graph, okay, for torque versus speed, okay. So already in your tabular form, speed values are there and torque values are there. You have calculated the torque values and you have note down the speed values from the digital display on your front panel of the kit, okay. So these are the values, okay. So as the voltage, control voltage varies, this graph will be vary, okay. So actually this is the theoretical torque versus speed characteristics of AC servo motor, okay. So the precaution to be followed while doing this experiment is, before switching on the supply, you must make sure that P1 and P2 are completely rotated in anti-clockwise direction or not. Okay, they must be in initial position, and this P1 and P2 should be operated very gently. Okay, they must be handled very gently. So the result is speed torque characteristics of a AC servo motor are plotted. That's all. So you have to plot the speed torque characteristics of this AC servo motor.